What if I told you your router is secretly gossiping with its neighbors? Dynamic routing protocols like OSPF and EIGRP are constantly sharing network secrets behind your back. In this video, I'll reveal how routers choose the best path and why sometimes they get it wrong. Watch now to master the hidden language of routing protocols.
A routing protocol is a set of processes, algorithms, and messages that routers share dynamically. OSPF, EIGRP, RIPv2, and IS-IS are dynamic routing protocols. There are two types of dynamic routing protocols. There are those with a distance vector and those with a link state. Distance vector routing protocols build routing tables themselves. However, no router has the overall view of the network, as the distribution of roads is only close to close. In the term distance vector, the word vector can be associated as a table that includes the other nodes in the network, and the word distance is the number of jumps that reach nearby routers. And in a link routing protocol, each router knows the full topology of the network. That is, routers don't rely on only their neighbors. Routers that run routing protocols exchange messages to keep their routing tables up to date. When a router realizes that there has been a change in the network, or a new route, then it will inform its neighbors who are part of the same routing protocol. In this way, all routers dynamically keep their routing tables up to date. Routers choose the best route to destination networks based on several criteria. We have the bandwidth. This is the debit of the link between routers. There's deadline. This is the time it takes for the IP packet to travel from one point to another. We have the cost, which is a predefined value and which a network admin can manually modify if it wishes. And we have the number of jumps, which is the number of routers that an IP package must travel before reaching its destination. To determine the best route to a destination, routing protocols use a metric. Each routing protocol has its own metric and its own way of calculating the shortest path using its algorithm. Metrics can be based either on a single criterion, such as the number of jumps for the RIP protocol, or on several criteria, as is the case with EIGRP. In general, the lower the metric value, the better the trajectory. Routing tables can be filled from three types of sources: directly connected networks, static routes, and routing protocols. The router must be able to evaluate routing information from all sources and select the best route to complete its own routing table. For this, they use a function called administrative distance. In cases where there are several routes available to the same destination, the administrative distance will allow you to select the best route. It is the one that defines the reliability of the route. The smaller the administrative distance, the more trusted the source of the route. Each type of source has an administrative distance by default. For example, directly connected networks have an administrative distance of 0, which prevents any further entry into the routing table for networks that are declared on the router. Static route has a default administrative distance of 1. This means that if you set up a static route, it will be given priority over all routing protocols, except if the destination network is directly connected to the router. And each routing protocol has its own administrative distance by default. For example, the administrative distance of the routing protocol RIP is 120. Let's see an example. Here, the router receives two routing updates, a message from OSPF and another from EIGRP. The metric used by EIGRP has determined that the best path to the 192.168.0.0 network is through IP 10 005. But the metric used by OSPF for the same subnetwork is through IP 172.1870. In this case, the router will have to use the administrative distance to determine the path that will be installed in its routing table. So what routing protocol do you think the router will choose? Well, in this case, since the administrative distance for the OSPF is 110 and 90 for the EIGRP, it will choose the EIGRP route and add it to its routing table. The routing protocol with the lowest administrative distance always wins when there are several paths in the routing table. With subnetworks, a destination address can match multiple entries in the routing table. In this case, it will be the most accurate network that will be given priority. A more accurate network is the smallest network. For example, in this routing table, there are two identical IPs with a different mask, A16 and A24. It will be the network with the 24 that will be selected because it has the highest mask, and therefore the smallest network.